Right, so let's go ahead and build this door buzzer circuit. So the first thing I'm going to need is a power supply, so I'm going to put my 9-volt power supply, and then I'll go ahead and I'm going to grab my buzzer, and we'll put in the buzzer like so. Now I want to connect up my power supply to my buzzer, so I'm just going to run a rail up the top there, down to the buzzer, as is. And now I'm going to go grab myself a little push to make switch, and we're going to put that in, and that's going to simulate where the contacts will go for us to put our finger on. I'm going to connect up the switch to my top rail up here, so I'll just draw a wire from my switch over to the top rail. And then we'll go get one of our transistors. We want this little NPN transistor here, and we can drag that on and place that in our circuit as well. So the first thing to do with the transistor is to connect the emitter up to the 0 volts of my power supply. And once I've done that, I can then collect the collector up to the buzzer here. So now when I get that small amount of current over at my base just there, then current will flow through the buzzer, through the transistor. So to get that current at the base of that transistor, I'm going to put another transistor and connect up the emitter of that transistor to the base of the first one I put in. And then the contact, where the finger contact is, that's going to go into the base of that transistor. And then what I'm going to do is I'm going to go and grab a resistor from my passive components menu over here, and I'm going to put a resistor in between that 9-volt positive rail of my power supply and the collector of my second transistor, and we'll set that to a 22k ohm resistor, just like that. Right, so now theoretically we've got a fully working circuit, and I could just stop here and leave it as is. When I hit the simulate button and hit my switch, you can see there that the buzz is sounding. But the client also wanted a visual representation of the switch had been pressed, so we want an LED in there as well. And I could put one in series with that buzzer, but unfortunately, if I was to do that, the current through that buzzer would cause the LED to pop. So what I'm going to do instead is I'm going to put a 330 ohm resistor over here and connect that up to the 9-volt rail, and then I can place an LED in series with that resistor, and that means that I can draw current through that LED without having to also go through the buzzer, because the current through the buzzer would be enough to pop the LED, and if I tried to reduce the current in the buzzer, it wouldn't sound. I'm going to make a couple of alterations here, so I'm going to change the type of the transistor I've got. So we're going to come down here to the model, and we'll just scroll on down, and we are looking for the BC547B, and the same for my second transistor over here. And then I've just noticed also that my resistor over here is a 330k resistor, and it should just be a 330 ohm resistor. So that's my circuit complete. I'm going to hit play here and just push that switch, and we can see our buzzer and our LED both come on, and that's our completed door buzzer circuit design.